to another... Where's the microphone? There it is. Hello and welcome to another Wednesday Hotfix. Today we're going to be not doing a video game. Today we're going to be learning how to convert from a hexadecimal color code into an RGB value. Because that's... I did yesterday. Why else would I be posting a video on Monday? Anyways, this could be a useful skill if you're doing anything like art related, but digitally. So you have RGB, which is red, green, and blue. So select these. We're gonna move them. Are you not select? You're select, yeah. So select. Select. Yes, I have here RGB. How do I move? Also, this border here is just stuff that won't really show up well if I color behind it. So like that, can't really see that blue line there. So, as we have our RGB values, let's okay, let me just like remove them and put them somewhere more convenient. So RGB values take that doesn't look good. RGB things take 3 inputs, 3 number inputs. That's good. Those inputs are 3 numbers each, so it's on open parenthesis. Here. And you put in 3 underscores, so it can be up to a 3-digit number. Then we're going to close that. Perfect. So those are numbers, which translates to somewhere between 0, all zeros here, and 255 for these. We'll just turn off the glitter. That's coming from that. Just turn it off. There we go. That's good. Okay. So then, of course, you also know how a hexadecimal color code works, which is you have the hashtag, then you have your numbers. 6 numbers. 1, 2, 3, 4, 5, 6. Now there are also 8-digit hex codes and RGBA values, but we're not going to bother with that since they're not used that often. What does the A stand for? In what? In RGBA?
Never heard it, sorry.
I think it's like brightness.
Could be A for amplitude. No, sure. I guess you could Google it, but I don't know.
Okay. Yeah. But each of these sections in the hex code here, section this off, are equivalent to the RGB parts. So this here is your R. This section is the G. And this section is the B. But that might not make sense, because how can they be equal when these take 3 numbers up here, and these on here are only 2 digits, but some of them can be letters. Okay, let's add a new frame and talk about how counting in different bases works. So up here in the corner, we're going to put our lowercase b, which is the base, equals and then we're just going to have whatever the current base is. So in base 10, so let's set b equal to 10 there. It's good enough. I'm not very good at drawing with a mouse, because, you know, it's a mouse. Like, there is a drawing tablet in this house, but it's my sister's, and I don't feel like getting yelled at right now, so. In base 10, you have your ones place. You also have your tens place. And your 100s place. There are different places. So let's say you want to do 255. That is a 5 in the ones place, or 5 ones. A 5 in the tens place, or 5 tens, or 50. And a 2 in the 100s place, 2 100s, or 200. A total of 255. But say you had, but in a way to standardize that, let's set b equal to, that's way too big. Let's actually set b equal to b. For that, okay, it doesn't look right. That's good. So in that case, what are the places? This is a way of standardizing it, so no matter what b is, it's always what's 1. When b is 10, you have the ones place. When b is b, you have the b to the power of 0 place, which anything to the power of 0 is always ones. That's always the ones place, no matter what number system you're using. It's always ones place. And I'm not going to need decimals. I'm only going up to 3, because that's all we're going to need for this. Then you have your b to the 1, to the power of 1 place, or your b place. Or say b is 10, that means it's the tens place. Then, of course, you have your b squared place, or b to the 2 place, which in base 10 is 10 squared, or 100. Now we can go ahead and apply that to other bases, such as, let me also have up here, add base 10 translation. So b equals 10 there. So that's our base 10, which is going to look like how you're used to it looking, because base 10 is what you probably use for most things. Let's have b equal to 2, base 2. So in that case, you have your 1's place, then you have your 2's place, and your 4's place. So let's have a 0 in the 1's place, a 1 here, and then a 2 there. We can't do that, because the amount of characters that you can use for the digits is equal to the base number, and since you start with 0, the highest is equal in value in base 10 to 1 less than the base number. Because if you look, this here looks like a 10, but because it's 0 1s and 1 2, it's a 2. In every base, that base is written as digit 1, digit 0, no matter what base you're in. So every base is base 1 0, but not every base is base 10. It's a fun little thing. But of course, since base 10 is what we usually use, the base character is standardized to the value equivalent in base 10. So, yes, let's have another one there. That is equal to 0 1s plus 1 2 plus 1 4 or 6. That's a 6. Yeah. Now, of course, if we had, say, base, hexadecimal is hexa, which is 6. Not very and decimal or deca, which is 10. So 6 plus 10 or 16. Hexadecimal there is base 16. So that means we have 16 characters, 0 through 9. But then what can we use after 9? In base 16, in the ones place, here is also the 16's place, and the 256 place. Also has one more than the 255 that RGB goes up to. I wonder if that'll be important later. But in each of these individual places, in each of these individual places, oh wait, you're not looking at the correct one. There you go. Sorry. In each of these individual places here, you can have a 0, a 1, a 2, 3, 4, 5, 6, 7, 8, 9. But then what comes after that? We could use letters. A, B, C. That is pathetic. D, E, and F. And no, I'm not doing them all uppercase because of my handwriting. They're meant to be all uppercase. So see here, we have this. And also the combination of the 1's place and the 16's place is enough to get to 255. We don't actually need this place for the hex part, but we will need it for base 10. So let's have, say, we have a 0, 0. 0 1's and 0 16's is equal to 0. Yay. We have D6. So D16's and 6 1's. Now pretending each of these is counting up. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. So that's D is 13 there. So that's 13 16s and 6 1's. Hey Google, what is 13 times 16? So that's 208 there. Plus, that's our 16s. That is not an addition sign, that is a floppy sort. Plus 6 1's, or 6, that is, pretend that was a 6. 208 plus 6 gives us 200. 2 100s. 4 1's and 1 10. So it's 214. So let's say we had there, let's say this is our red section of that their RGB value. Okay, I'm just going to take you back to that one there. Yeah, we're back here now. Nice. So our RGB, let's say that 06 there from the D6, that was a D6, was in our red there. That D6, that was our RGB and it was 214. Why did I just put the 4 in there with the 1? 214. Now what should our G be? Let's go with 37. And then B, F9. Look at that. Look at that. Okay. So we have what we need now. 37 there isn't equal to 37 here, though. 37 there is equal to 3 16s and 7 1s. Not 3 10s, 3 16s. Which is 30 plus 18. Or 48. Plus 7. 48 plus 7 is 48 plus 2 plus 5, or 55. So we have the G, as that looks too much like a D. 0, 5, 5. And then our F9 there, F is 15 16s, or 240. And 9 is 9 ones. 249. That gives us 249 in the blue there. So if all these were F, they would all be 15. Which 15 16s plus 15 ones is equal to 1 short of 16 16s. 16 16s is 256. That gives us 255. So if these are all F's, these are all 255, which gives us all of everything in every color, which gives us black. Now if these are all zeros, these would all be zeros, so you have nothing, which is white. Now if you want to know what this color is, well, let's see. Let me just pull up a new tab here. In Chrome, you can't see this. I'm going to have to type, so I'm going to have to set the mic down. I've been holding the mic this entire time. Okay. Color picker. Perfect. Here we go. Let's put in our RGB there. Well, this thing also allows you to put in a hex and get an RGB. So we're going to put in that hex code there. D637F9. Let's say D637F. That's an R. F9. Perfect. Ooh, that's a nice color. And it gives us a 214R, 55G, and 249B. So, yeah, that's correct. We did the math right. Did the math. Now let me just Windows Shift S there. That. Then head back here. Control V. I said Control V. Okay. Add image. Okay. Okay. Give me the Windows Shift S. Grab the screenshot of this, please. Grab this. Save to clipboard. That color. Back here. Okay. Give me pictures here. Example color. There we go. Open that up. There's our color. This is the color. That's cool. I like that. That's fun. There's the color. So, now you should know how to convert from hexadecimal color codes into RGB values, and also find something where I can plug in either to get a color. So that's the color. Okay, bye. See you tomorrow with gameplay of a game. Not this. This is just a one-time thing that I just wanted to make. Okay, bye.